grade math, welcome back. We are starting in your exponent packet. So go ahead and turn to the next page. And we'll continue with the properties of exponents. So as you just did yesterday, when you have two of the same bases multiplied, you add exponents. So 4 to the 2 times 4 to the 4 is 4 to the 6. Basically there's 2 4's here and 4 4's here. So you just add those. In number 2, you have 3 5 to the negative 2's. So you add the exponents, so that would be 5 to the negative 6. When you're looking at a power to a power like this, you can also think of it as multiplying these two numbers. So negative 2 times 3 is negative 6. Now there's a slight little thing with negative exponents. I will make a table right here. Think about 2, because that's an easy number to work with. 2 to the 0, anything to the 0 power is 1. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. 2 to the 4 is 16. Now if you go backwards, 2 to the negative 1 is 1/2. See how you're multiplying by 2 as you go up? So if you go back, you would need to divide by 2. So 2 to the negative 2 would be 1/4. That's like 1 over 2 to the 2. And 2 to the negative 3 would be 1 over 2 to the positive 3, which is 1/8. 2 times 2 times 2 is 8. So 5 to the negative 6 you need to rewrite as 1 over 5 to the positive 6. And you can just leave it in exponential form. So when you have 5 squared over 5 to the 8, that means there's 2 5's on top and 8 5's on the bottom. Now 2 of these cancel, so this you are left over with 1 over 5 to the 6 also. If you remember from that front page, when you have exponents divided, you could actually do 5 to the 2 minus 8 and get your answer. Number 4, this 3 means that there are 3 of these. So that is 3 to the 3rd over 7 to the 3rd. You could also think of putting this 3 through to both. Now, a 2 to the negative 9, a negative exponent, if you move it to the opposite side of the fraction, it becomes the opposite sign. So this is 2 to the 2 times 2 to the positive 9. This moves up and changes sign, which means this simplifies as 2 to the 11. When you have a negative with the number, that doesn't change signs. It's only the exponent that you change signs with. Since this negative 9 is in the front with no exponents, it just is like an exponent of 1. So this is negative 9 to the 4. There's 4 negative 9's. You do need to keep this in the parentheses because the negative is to the power of 4. It's a little bit different if it's not in the parentheses. A to the 6 times a to the 3 is a to the 9. You are just adding the exponents. X to the 5th squared means there's 2x to the 5th. That's x to the 10. You are multiplying the exponents because it's a power to a power. And this 5 goes through to each. So it's 4 to the 5th. And then a squared to the 5th, that's a to the 10. And then b cubed to the 5th, which is b to the 15th. Now, you can use your graphing calculator and figure out the 4 to the 5th. There is a caret button above the division sign. So 4 to the 5th. And then hit enter. 1024. So these numbers you should simplify because it says, it says simplify, yes, that is why. The next one, you would be subtracting the exponents, or you can think of it as canceling them out. So x to the 2. Go ahead and hit pause and try 11. This would give you 1 over x cubed. If you think about subtracting them, it would be x to the 5 minus 8, which is x to the negative 3, and then you need to move that to the bottom. It might be easier to think about it as 5x's on top and 8x's on the bottom, and then canceling the 5. And you're left with 3 on the bottom. Since there's nothing on top, you do need to put a 1 because a 0 makes everything 0 and a 1 doesn't do anything. X to the 6 over x to the 6, they both cancel, so you're left with 1. Just like 2 over 2 is 1. In 16, we're going to take the negative exponents and move them up. So y to the negative 1 goes up and becomes a y to the positive 1. X to the negative 3 goes up and becomes an x to the positive 3. So this is x to the 14 because you're adding exponents, and y to the 11. In 17, anything to the 0 power is 1. So we actually really don't even need to look at the y to the 0 because that's just 1. So you have negative 3, and then the x to the negative 4 needs to move to the opposite side of the fraction, and it becomes positive. Okay, 18, I cut that off. So this reads 5x to the 3rd y to the 9 over 20x squared y to the negative 2. The y to the negative 2 is going to move sides. That moves up and becomes a y to the positive 2. So this is gone. 5 over 20 is just like fractions that you've always worked with. So you're going to just take a 5 out of both. So 5 out of 1 is, or 5 out of 5 is just 1. And how many 5s are in 20? That's 4. So 5 over 20 is the same as 1 over 4. Now there's 3 x's on top and 2 x's on the bottom. So this whole thing simplifies to just x to the 1. And then the y to the 9 and the y to the 2 you add, and that becomes a y to the 11. So you have an x to the 1 on top, a y to the 11 on top, and that 4 on the bottom. If you want, you can put the 1 of the 1/4 on top, but you don't need to. 19, you have a negative 2 on the bottom. You're going to move that up to the top and make it positive. So x to the 5th times x to the 2 is x to the 7. You add exponents when you multiply. In 20, y to the 0 is 1. You have an x to the 5th over an x to the 4th. That's just an x to the 1 because you subtract exponents, or you can think of it as canceling. You don't even need the 1 when you have the x. So you could just put xy squared. You could put the 1 with the x, it doesn't matter. Anything to the 0 power is just 1. When you have a power to a power, you multiply. So this is really x to the 0, which is 1, because if you have no x's, you still have this 1 out front, but really you have no x's. In 22, this negative 3 is going to go through to each of these things. So 10 to the negative 3, x to the 5 times negative 3, which is negative 15, and y to the 3 times negative 3, which is negative 9. Now, negative exponents are improper, so we're going to do 1 over, because every single thing needs to move, 10 to the 3rd, x to the 15th, and y to the 9th. And then you really should simplify 10 to the 3rd. It's 10 times 10 times 10, which is 1,000. So So 1,000, 1 over 1,000, x to the 15th, y to the 9th. That's your simplest form. So here's where we get to practice with moving numerators and denominators down. An x to the negative 1 goes to the bottom and becomes an x to the positive 1. And then the y to the negative 2 needs to move up, and that's going to become a y to the positive 2. So in the numerator, there's a y to the 1 and a y to the 2. That is a y to the 3. And in the denominator, there's an x and another x, which is an x squared. In 24, you are taking that negative 2 through to each thing. So 4 to the negative 2, x to the negative 4, because 2 times negative 2 is negative 4, and y to the 5 times negative 2, which is negative 10. Each of these things need to move, so 1 over 4 to the positive 2, x to the positive 4, y to the positive 10, that is 1 over 16, x to the 4, y to the 10. Go ahead and hit pause, try the next 3, and then I'll go through them. See if you're getting the hang of this. So 25, you have a 2 over 6. That's a 1/3 because the numbers are just treated as numbers. The y to the negative 1 needs to move up and become a y to the positive 1. And then the x to the 2 over a single x is just an x to the 1 because one of the x's cancels. So you are left with an x on top, a y squared on top, and a 3 on the bottom. If you would like to put that 1 from the 1/3 up there, you can, but it is unnecessary. In 26, this y to the negative 2 moves up and becomes a y to the positive 2. So the whole numerator now is negative 7 x y to the 10th, because there's a y to the, not 10, y to the 9, y to the 2, and a y to the 1, so it's a y to the 12th. You could put a 1 with the x if you want. And then the whole bottom is 3 times 21, which is 63, and then there's an x to the 5th. So 7 times 9 is 63. So this is going to reduce to 1, and this to 9. And then there's an x to the 1 on top and an x to the 5 on the bottom. So if you think about crossing one of the bottom ones off, the x to the 1 on top is gone, and then there's 4 left on the bottom. So this whole thing simplifies into negative, you could put the 1, you don't need to, y to the 12 over 9x to the 4th. Okay, the next one has no negative exponents, but I will tell you that the easiest thing to do before multiplying everything is to cancel what you can. Anything on top can cancel with anything on the bottom. So the 7s right away can completely cancel. And 12 over 4 is just 3. So you can make that a 3. Now in the numerator, let's go ahead and kind of simplify at this point. There is 1x and 5 x's, so that is 6 x's. Then there is 3 y's, and in the denominator there is an x to the 4 and a y. So x to the 6 over x to the 4 is just an x squared on top, and a y to the 3 over a y to the 1 is just a y squared on top. So that is your simplest form. On the next page, this is just explaining exactly what we just did with negative exponents and 0 powers. So we'll jump straight to the problems below that. Now, this worksheet looks a tad bit weird, but it's really just a bunch of space to show your work. So 2 to the negative 5th is the same thing as 1 over 2 to the positive 5th, and then 2 to the 5th is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32. So the answer is really 1 over 32. In number 2, 10 to the negative 3 is the same thing as 1 over 10 to the positive 3. So that's 1 over 10 times 10 times 10, which is 1 over 1,000. Number 3, 1 over 5 to the 4. This time you're moving this up. That's 5 to the positive 4. And 5 to the positive 4 is 5 times 5, which is 25, times another 5, which is 125, times another 5, which is 625. Number 4, you are moving the y to the negative 4 down. So the 5 stays on top, and then the y in the denominator is now a positive 4. Number 5, the a to the negative 3 moves up, so the 8 stays up, and now it has an a to the positive 3 next to it. In 6, the y to the negative 2 moves down, so 9x cubed stays where it is, and the y to the 2 is positive, and it's now on the bottom. Go ahead and hit pause, try the next 3, and see how you do. In 7, the x to the negative 1 needs to come up, so this is x to the 4 over y. In 8, the b's do cancel, so there's one b left on the bottom. And then the a needs to move up, so there's one a on top. So a over b. You could put 1s in the exponents if you want. You don't have to, but it's an option. And then in 5, the x to the negative 4 moves down, so it's 5y squared over x to the 4. And then when you flip it over, we're just going to plug in numbers and solve. You probably are going to need a calculator. Evaluate means to actually solve. So x to the 2 is negative 2 to the 2, and y to the 0 is 5 to the 0. Now anything to the 0 is 1 power, so I'm just going to cross that off. And negative 2 to the 2 is, the whole negative is plugged in. So negative 2 to the 2 is negative 2 times negative 2, which is 4. This is different than a negative out front. If you had negative 2 squared, that negative would stay out front, and that answer would be negative 4. So you do actually need to put these parentheses in, and your answer is 4. 4 cubed and 2 cubed. 4 times 4 is 16, times another 4 is 64. 2 times 2 is 4, times another 2 is 8, and 64 times 8 is 512. In 12, you can go ahead and move this up. There's no reason for it to be in the denominator. So z cubed y squared. So 2 cubed is 2 times 2 is 4 times 2, which is 8. And 5 squared is 5 times 5, which is 25. And if you have 8 quarters, you have $2. So 8 times 25 is 200. This time you have the negative out front. So in parentheses, we're going to have our 2 cubed, that negative is out front, and then the b to the negative 4, let's go ahead and just move that down. So that's a b to the positive 4. So that in the denominator is negative 1 is what you're plugging into b to the positive 4. Now, a negative times a negative is a positive, so any even exponent of negatives is a positive. So this whole denominator is just equal to 1. And then in the numerator, there's this negative 1 out front. So 2 times 2 is 4 times 2 is 8. So your whole answer is negative 8. Go ahead and hit pause, try the next 2, and see how you do. In 14, you have n to the negative 2 over m to the 4. Let's go ahead and just move the n down first and the m up. There's no need to stress over negative exponents. Okay, so you have 6 to the 4th, over 2 squared. So 6 times 6 is 36, times another 6 is 216, times another 6 is 1,296. And 2 times 2 is 4. And when you divide that out, you get 324. This is in parentheses. This is a negative exponent. So we're going to make this a negative u squared over v to the 6. So that is just a negative, and then you plug the 2 in, and then you put the parentheses in, squared over 2 to the 6. So negative 2 times negative 2 is 4, and 2 to the 6 is 64. And then this can be reduced because 4 goes into 64, so this is really 1 over 16. Anytime you can keep something in a fraction form and not have a decimal, that is a lovely thing. I'm going to have you skip over 7-1 practice because I want you to do that as homework and move into 7-3. So this should be pretty smooth. We've already done this. When you multiply, you add exponents. So that's a 3 to the 5th. Again, there's a bunch of work here. So you have 4 5s and then 2 5s. So that's 5 to the 6th. And then you have 3 4s and another 3 4s. So that is 4 to the 6th. And you have 3 2s and then 2 2s, so that is 2 to the 5th. And 6 to the 3rd times 6 to the 4th is just 6 to the 7th. I would just leave it in exponent form. So when you multiply the same base, you are adding exponents. So this would be a to the m plus n. Oops. You can go ahead and hit pause and see if you can get these answers. 5 to the 8th, just adding. 7 to the 4, adding. 10 to the 12, 8 to the 10th. If you flip this over to 8, you kind of work parentheses from the inside out. So 4 to the 2 cubed means you have 3 4 to the 2's. So that is 4 to the 6. But then you still have this 3. So now if you have 3 4 to the 6's, you really have 4 to the 18th. So as you can see here, you have 4 mn's. So you have 4 m's and 4 n's. So this is really m to the 4, n to the 4. In the next one, there are 2 xy's. That means there's 2 x's and 2 y's, which just means your final answer is x squared, y squared. And then in the next one, you have 5 CDs, which means you have 5 C's and 5 D's, which your final answer is C to the 5th, D to the 5th. And you can probably just jump right to your answer here as P to the 6, Q to the 6. So when you have a power to a power, if you kind of look down at the number 3, well, hold on. So if you have x to the a to the b, it's really x to the a times b. And if you have an exponent outside of the parentheses, you take that through to both. So a to the n, b to the n. I'm not really sure why I wrote this, but that's a good thing to know too. So, I'm going to have you also do this 7.3 lab recording sheet for homework. On the back. And then 7.3 practice B. You have 3 to the 4th times 3 squared. That means there are 4 3's here and 2 3's here. So altogether there are 6 3's total. I'm hoping that you understand the little rule that when you are multiplying exponents, you add them. So in number 2, 2 to the 5th times 2 to the 4th would mean you have 2 to the 9th, 9 2's total. Number 3, 2 to the 3rd, 2 to the 5th, 2 to the 1. So that's 5, 6, 7, 8, 9 2's total. Number 4, q to the negative 8 and q to the negative 1 is a total of negative 9 q's. Now this is where it gets a tad bit weird. Negative exponents are improper. So if you think about a little table, 2 to the 0 is 1 because anything to the 0 power is 1. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 2 times 2, which is 4 times 2 is 8. And 2 to the 4 is 8 times 2, which is 16. So as you're going up, you are multiplying by 2. So as you go down, 2 to the negative 1, you would divide by 2, and that is 1/2. And 2 to the negative 2 is 1 over 2 to the positive 2, which is 1/4. And 2 to the negative 3 is 1 over 2 to the positive 3, which is 1 over 8. So a q to the negative 9 is actually best written as 1 over q to the positive 9. So if you have a negative exponent, you should move it to the opposite side of a fraction. In 5, r cubed and r to the 4th, when you add those, you get r to the 1. You don't have to put the 1. You could just leave the 1 alone. S doesn't have anything to go with, but it is a negative exponent, so it needs to move to the opposite side, and it becomes the opposite sign. So when you move it to the bottom, it becomes positive. If you have a negative exponent in the denominator, if you move it to the numerator, it becomes positive. All right, a j to the negative 2 and a j to the positive 2 is nothing. So this all simplifies j to the negative 4. Now you cannot have a negative exponent because it is improper, so this is actually written as 1 over j to the positive 4. In number 7, a c to the 5th and a c to the 3rd is a c to the 8th. And then you have that b to the negative 2. The b to the negative 2 needs to be moved, so that is c to the 8 over b to the 2. In 8, okay, that's a 5. So you have 5 h squareds. You can kind of think of it like this, which means you have 10 h's. Now, another way to think about exponents when you have these parentheses is a power to a power you actually multiply. So you could think about this as h to the 2 times 5, which is h to the 10. So in 9, if we think about it that way, g to the 4 to the negative 2 is really g to the negative 8. So that can be rewritten as 1 over g to the positive 8. Have a lovely evening, and we will pick up where we left off. If you want to work ahead, that is a great idea.